The next topic that we want to look at are systems of equations, but this time using the elimination method. So the goal here is to use the elimination method to solve systems of equations. So this is just a different method than we did with substitution. So the idea here is that we're going to want to add the two equations together, and when we do that, somehow eliminate one variable. So we need to think of what can we multiply each equation by so that when we add them together, one of the variables does go away. So here I have this example. 3x minus 4y equals 8 and 5x plus 4y equals negative 24. And what you notice is that in my first equation I have negative 4y, and in my second equation I have a positive 4y. So what we can do is add these two equations together. And when we do that, we get 8x. The y's will cancel because negative 4y plus 4y is 0. And that's going to equal negative 16. And then I can solve for x by dividing both sides by 8 to get x equals negative 2. Once I get that, then I can plug this value into either one of the equations. It doesn't matter. I'll just pick the first one. If I plug in negative 2 for x, I'll get 3 times negative 2 minus 4y equals 8. So 3 times negative 2 is negative 6. I'll go ahead and add 6 to both sides and get negative 4y equals 14. Divide both sides by negative 4. So then y is 14 over negative 4, which reduces down to negative 7/2. So then our solution is going to be negative 2, negative 7/2. So again, the idea is that we're going to add the two equations together. One of the variables should go away. So here's our first example. Negative 6x plus 5y equals 22. 2x plus 3y equals 2. I can't just go ahead and add them together as is. The reason is because one of them is not going to go away. So what I want to do is I want to somehow add them, multiply one of them by a value so that I can add them together and cancel. What I can do is, let's say I multiply the second equation by 3, and let's think this through before I actually do it. If I multiply the second equation by 3, I'll do it over here to the side, I'll end up getting 6x plus 9y equals 6, which is good because then when I add them together, I'm going to have a negative 6x and a positive 6x. So I think that's going to be our choice. We're going to multiply the second equation by 3. So when I do that, I'll get negative 6x plus 5y equals 22 for the first one. Haven't changed that at all. But for my second one, 6x plus 9y equals 6. So we'll add them together. The x's go away, and I get 14y equals 28. Then we'll divide both sides by 14 to solve for y, so y equals 2. We just need to figure out what x is now. So to do that, pick either equation. It doesn't matter which one. The values are a little bit smaller on the second one, so I'll pick that one. And I'll plug in y equals 2. So 2x plus 3 times 2 equals 2. 3 times 2 is 6. So I'll subtract 6 from both sides and get 2x equals negative 4. And then divide both sides by 2, so x equals negative 2. So our solution this time was negative 2, 2. Now let's look at 3x plus 6y equals negative 9. 2x plus 9y equals negative 26. Okay, so this one's not 100% obvious on what we should multiply by in order to get some sort of elimination happening. Because the values are a little bit smaller for my x's, I think it makes sense to deal with those. So what I can do is I can look at the least common multiple of the two coefficients. So the least common multiple of 2 and 3 is 6. So what I want to do is I want to rearrange this so that one of them has a positive 6 as the exponent, and one of them has a negative 6 as the exponent. Not exponent, coefficient. To go from 3 to 6 in this first equation, I need to multiply by 2. So if I multiply the first equation by 2, it'll be 6x plus 12y equals negative 18. For my second equation, to go from this 2 to negative 6, I want to multiply by negative 3. So I'll multiply the entire equation by negative 3. So 6x minus 27y equals, oh, and now we got to do negative 26 times 3. That's tough to do, so I'm going to do it off to the side. So let's see, 18 times 6, 78. Sounds right. So 78. Good. Now we have coefficients that are going to eliminate when we add. So I'll add these two together, the x's go away. 12 plus a negative 27, I believe that gives us 15, negative 15y equals 60. Then I'll divide both sides by negative 15, and it looks like y is negative 4. To figure out x, I can use either one of these two equations. I kind of like this first one better because the negative 26 is such a large number. So I'll use that. 3x plus 6y equals negative 9, and I'll plug in negative 4 for y. So 3x plus 6 times negative 4 equals negative 9. Let's see, 6 times negative 4 is minus 24. I'll add 24 to both sides. And that looks like it's going to give me 15. And then divide both sides by 3. So it looks like our solution here was 5, negative 4. Whenever you don't really know what to multiply by to cancel. So on this one, I don't think it's obvious. I would look at which variable has the smaller coefficients, and for us it was x. Then find the least common multiple, so that was kind of our first step. Second step was find the least common multiple, and that's what your new coefficient is going to be. Then multiply, so this was our third thing we did, multiply so that you do actually get that coefficient. Let's do this example. I have 2x minus 5y equals 3, negative 6x minus 15y equals 9. So the smaller coefficients, it looks like those belong to x. The nice part is that negative 6 is already a multiple of 2, so I don't have to do the whole least common multiple because it's already there. So I'm going to leave that second equation alone. But I want to get a 6x where I had a 2x before. So that means I should multiply the first one by 3. All right, so I multiplied the first one by 3, which is not a 6, that is a 9. And let's go ahead and add them together. So the 6x's go away. I am left with negative 30y equals 18. So I'll divide both sides by negative 30. This is getting kind of messy here. But I get negative 18 over 30 from my solution, which, see, they're both divisible by 3. So that would be negative 6 over 10. And that'll even reduce down further, negative 3/5. Once I have y, I'll plug it into, looks like that first equation might be a little bit easier. So 2x minus 5y equals 3. And I'll plug in negative 3/5 for y. So 2x minus 5 times negative 3/5 equals 3. Negative 5 times negative 3/5 is a positive 3. So I'll subtract 3 from both sides and get 2x equals 0. So x equals 0. So my solution, 0, negative 3/5.